Reduced gray matter in the brain and its effects on judgment. The human brain is a complex and highly evolved organ responsible for managing a wide range of cognitive functions, behaviors, emotions, and perceptions. An important aspect of brain structure is gray matter, which is composed of neuronal cell bodies and synapses and plays an important role in processes such as memory, decision-making, and movement. Recent studies have shown that reduced gray matter can have a profound impact on cognitive functions, especially judgment. In this context, judgment refers to the ability to make rational decisions based on available information, assess risks, and take appropriate actions. This is an important skill for humans to survive and succeed in daily life. Reduced gray matter may impair this ability, leading to misjudgments, impulsive decisions, and potential challenges in reasoning or problem-solving. What is gray matter? Gray matter is one of the two main components of the central nervous system, the other being white matter. It is mainly composed of neuronal cell bodies, dendrites, glial cells, supporting cells, and synapses. Gray matter is responsible for processing information in the brain, rather than transmitting signals, which is the main role of white matter. The structure of gray matter allows it to play a key role in a variety of neurological functions, including sensory perception, muscle control, and emotional regulation. It is primarily found in the cerebral cortex, where the brain's higher-level functions, such as thinking, reasoning, and memory, occur. While the terms gray matter and white matter may sound simplistic, their roles in brain function are not, making gray matter a critical component of overall cognitive health. The density and volume of gray matter vary from person to person and can fluctuate based on a variety of factors, including age, gender, mental health, and lifestyle. Gray matter volume changes throughout a person's life, typically peaking in childhood and slowly decreasing as they age. However, the loss of gray matter can be accelerated by injury, neurological disease, or even lifestyle choices, leading to significant changes in cognitive abilities. Gray matter loss is often referred to as gray matter atrophy, and can occur for a variety of reasons. Aging and gray matter loss. Aging is the most common cause of gray matter loss. As people age, their brains naturally undergo structural changes, including a gradual decrease in gray matter volume. This decline has been linked to a range of cognitive impairments, including slower processing speeds, difficulty multitasking, and especially impaired judgment. Research suggests that the prefrontal cortex, which plays a key role in judgment, decision-making, and problem-solving, is one of the areas most affected by age-related gray matter loss. Thinning gray matter in this area can lead to decreased cognitive flexibility and an increased tendency to make impulsive decisions. Traumatic brain injury. Traumatic brain injury (TBI) can result in significant gray matter loss. TBI occurs when an external force causes the brain to move rapidly within the skull and cause damage. Such injuries are common in car accidents, falls, and sports-related incidents. Severe TBI can lead to long-term cognitive impairments, including problems with judgment and decision-making. Neurological disorders. A variety of neurological disorders have been linked to gray matter loss. Diseases such as Alzheimer's disease, multiple sclerosis, schizophrenia, and Parkinson's disease all contribute to gray matter shrinkage in different ways. Mental health disorders. Mental health issues, especially chronic stress, anxiety, and depression, have been linked to gray matter loss. Research shows that chronic stress leads to an overproduction of cortisol, a hormone that damages neurons and causes gray matter loss in the hippocampus and prefrontal cortex. Chronic sleep deprivation. Sleep plays a vital role in maintaining brain health. During deep sleep, the brain undergoes restorative processes that help repair and regenerate neural tissue. Chronic sleep deprivation can lead to gray matter degeneration, especially in areas associated with executive function and judgment. Effects of reduced gray matter on judgment. Reduced gray matter can have a profound impact on cognitive function, especially in the area of judgment. Here are some of the most notable effects of gray matter loss on judgment. The ability to assess risk is a key component of sound judgment. It involves evaluating potential consequences, considering the likelihood of different outcomes, and weighing the pros and cons of various decisions. Gray matter loss, particularly in the prefrontal cortex, impairs this ability, causing individuals to underestimate risk or make overly cautious decisions. The tendency to act impulsively, or without thinking, is closely associated with the prefrontal cortex, which is responsible for regulating behavior and controlling impulses. Reduced gray matter in this area can lead to increased impulsivity, making it difficult for individuals to delay gratification or weigh the consequences of their actions before making a decision. Increased impulsivity can manifest in a variety of ways, from making rash financial decisions to engaging in risky behaviors like substance abuse or unsafe driving. It can also affect social interactions, as individuals may have difficulty regulating their emotions or reactions in challenging situations. Problem solving is another cognitive function that relies on the integrity of the brain's gray matter, particularly in the frontal lobes. When gray matter is reduced, individuals may have difficulty analyzing complex situations, identifying potential solutions, and choosing the best course of action. This impairment can affect everyday decision-making as well as more complex tasks that require critical thinking and planning. People with reduced gray matter may have difficulty adapting to changing situations or coming up with creative solutions to problems. Judgment is more than just a cognitive function. It also involves emotion regulation and the ability to balance emotions with rational thinking. Reduced gray matter, particularly in the areas of the brain responsible for emotion processing, can lead to emotional dysregulation, making it more difficult for individuals to make balanced and informed decisions.